Find the distance from A to C. We have ourselves a number line and three dots that are on that number line, also known as being collinear. And I have to find out how many units I go from A to C. So let's count it out. 1 unit, 2 unit, 3 unit, 4, 5 unit, 6 unit, 7 unit, more. Also known as 8. So we could say AC is equal to 8. And there you have it. That's it. We're done. Ooh, the segment addition postulate. The segment addition postulate says if I have a bunch of segments stuck together that you can add those segments up and it'll equal the whole thing. So let's see what I know. I'm supposed to find IK. I'm supposed to find from here, let's go to pen, from here to here. I know you're 12, but I don't know KL. Ooh, but I do know that JK plus KL is 31, which means if I want to find KL here, I could do 31 minus 12. 31 minus 12 is 19. Okay, so let's get rid of that question mark. Now you might be thinking, that's not going to help me because I need IK, not KL. I know, but I'm working towards something here. What I also know is IL is the whole thing is 49. I know that JK and KL add up to make 31. So if I wanted to find out what IJ was, I could do 49 minus 31, which is 18. In a way, it was kind of useless. It was kind of pointless to find KL because eventually I didn't really need that, but I had fun doing it, so it's too late now. Am I done? No. Because I have to find IK. Still haven't found that yet. But IJ is 18 and JK, just kidding, is 12. And IK is 18 plus 12. So IK is 30. Oh, 30. That's going to be my age in a few years. Hee. Just kidding. That ship has sailed a long, long, long time ago. But I still sound great. Like and subscribe. Find DE, which is this chunk right here. This uses the segment addition postulate, which says if I add you and add you and add you, I get this whole thing. So since I'm given information about each little segment here, let's just do that. Let's add them all up. DE is 3x minus 28 plus EF is 3x minus 30 plus FG, which is just x, and all of that equals 33. If you have nothing in front of a parentheses, you don't need the parentheses. So this leaves me with 3x minus 28 plus, again, nothing in front of a parentheses, 3x minus 30 plus x equals 33. Let's combine some like terms. We got 3x, we've got another 3x, and we've got 1x, so that's 7x. We've got negative 28 and negative 30, which is negative 58, and that equals 33. Now it's just a regular two-step equation. Let's add 5, 8, 58. I don't know why I said 5, 8, but I did. I'm not changing anything. 7x is going to equal 91. Last step, since 7 is attached to x, let's detach it by dividing everything by 7. And 91 divided by 7 is 13. Now, before I circle that and be like, Dunzo, I'm not. It didn't ask me to find x. It asked me to find DE. But the only way that I could find DE is by finding x and now plugging it into that guy right there. So DE is 3 times x. 3 times 13 minus 28. Running out of space. So 3 times 13 is 39. 39, oh my gosh, 39 minus 28 is 11. So DE is 11. No units to worry about, no centimeters, no inches. Just 11, baby. We found it. Find the measure of angle MLP. Here's M, here's my vertex L, here's P. Now this angle is clearly greater than 90. So when we measure starting from N, hit L and go over to P, we're looking at two numbers. Now you can't really tell what those numbers are, but you have either between 120 and 140 or 60 and 80. Well, it's not the 60 and 80. We already determined that this is an obtuse angle, so it's got to be greater than 90, which means it's the number between 120 and 140, which is 130 degrees. So that's how you read a protractor. This means the measure of angle IHQ. So find the measure of angle IHQ if the measure of IHG is 176 degrees and the measure of QHG is 130 degrees. This is going to use what's called the angle addition postulate. The angle addition postulate says if I have two angles like this one right here and this one right here, glued together, I can add them up and equal that whole thing right there. What I know is IHQ is, I don't know, actually. That's what I needed to find. So we'll call UX. IHG, let's use a different color. IHG is this whole thing. So IHG is 176 degrees. QHG, this guy right here, is 130. So X plus 130 is 176. X plus 130 is 176. Why? Because the two smaller angles add up to make this big green angle here. All I have to do for this guy is subtract 130 degrees from both sides, and X is going to equal 46, my current age. Now, I'm not going to call it X. I just used X as a variable. So what I'm going to do is go back to the original thing that it asked me to find. The measure of angle IHQ is 46 degrees. Okay? Angle addition postulate with really basic numbers, nothing crazy, no wacky problems. You could solve this without using an X. You could solve this using common sense just by saying, isn't it just 176 minus 130? Yep. But I got a little bit more involved because more time doing these problems means more YouTube money for me. And I'm all about lining those pockets, baby. That's why I keep talking at the end of these videos sometimes. Maybe those precious extra seconds will help feed my family. Also, I'm not 46. I'm a little younger than that. A little. Like and subscribe. Find X if angle 1 is 3x plus 5 and angle 2 is x plus 15. Angle 1 and 2 are completely next to each other. These two are supplementary. In other words, they both are glued together to form a straight angle. So if we were to add these up, so 3x plus 5 and x plus 15, they add up to 180 because they form that perfectly straight line. Combine like terms. 3x plus x is 4x. 5 and 15 make 20. And then that equals 180. Subtract 20 from both sides. 4x equals 160. Divide by 4. And you got x equals 40. The measure of angle GFN equals 4x plus 10. The measure of angle NFE, not to be confused with NFTs, is 14x plus 3. The measure of angle GFE is 157. Find the measure of angle NFE. All right, let's label some stuff. GFN is 4x plus 10. So let's sneak that in there. Okay. NFE, thank goodness, is going to be 14x plus 3. GFE, this whole thing is 157 degrees. Which means I can set up an equation that says 4x plus 10 plus 14x plus 3 equals 157. Why did I put those parentheses there? Just because you should always put parentheses when you substitute, even though in geometry, more often than not, you don't need them. But one of these days it might be needed, so the parentheses are there. Although since there's nothing in front of the parentheses or just a plus sign in front of the parentheses, we don't need them. So I'm getting rid of them. Okay? So now we have ourselves a pretty gross-looking equation, but I do have stuff on the left, like 4x, like 14x, that combine to make 18x. I have 10 and 3, which I think is 13, and that equals 157 still. Now it's a two-stepper. In order to get x all by itself, we have to get rid of 18, but let's get rid of 13 first by subtracting 13 from both sides, like so. 18x equals 144. Divide both sides by 18. And that's going to end up being 8. Of course, I did that off my head, and I didn't pause the video so I could ask Siri to do it for me. X is 8. Are we done? No. It's not asking me to find x. It's asking me to find NFE. NFE is 14x plus 3. So the measure of angle NFE is going to be 14 times x, which is now 8, plus 3. 14 times 8 is, of course, 112. Again, I didn't ask Siri and pause the video. I just did it in my head. 112 plus 3 means the measure of angle NFE. I keep wanting to write NFL, but I didn't. It's 115. By the way, the NFL does not sponsor any of my math videos, but if they're interested, just let me know, NFL. Let me know, Goodell. I'm a big Eagles fan. So just give me a call. Find x. What do we have here? We have a picture where I have two angles that are across from each other. Oh, these are called vertical angles. When two angles are created by you either crossing over like so, angles that are opposite of each other are called vertical angles, and vertical angles equal each other. So, in this case, 2 plus 3x is going to equal 62 because these guys are vertical angles. Okay, so let's get rid of the parentheses. Let's add some color and get rid of the parentheses. Don't need the parentheses. I just put them there because they were over here. I have to get x all by itself. 3 is attached to x, but let's get rid of 2 because it's floating. Cross you out. 3x is equal to 60 now. Now it's a one step. In order to get rid of 3, we have to divide 3 from both sides, like so, and x is going to equal 20. And that's all we had to do. Just find x. It's not really necessary to put a parenthesis or a degree symbol there just because x represents a variable and not a measurement. But, if you did, I don't think your teacher would mark you wrong. I certainly wouldn't. You might have a mean teacher that would. But x is 20. Ooh, speaking of 20, that's how many years old I was a few years ago. Find x where this angle right here is 29. This angle right here is x minus 24, and this huge angle is 296. Now, do these guys add up to make 90? No. Do these guys add up to make a straight angle? No. So not 180. Do these guys equal each other? No, I don't think so. It doesn't look like they do. What do we know? Well, they had to give us that 296 for some special reason, and that's because the only way we're going to do this is the fact that an entire circle, an entire angle spun around beginning to end is going to be 360 degrees. So my job is to find x, where I know that this angle is x minus 24. I know that this angle is 29, so we'll add 29. The rest of a circle is going to be 296, and that whole thing is going to equal 360 degrees. So that'll help us find our x. So let's get rid of the parentheses, don't need them. X minus 24 plus 29 plus 296 equals 360. Negative 24 and 29 make 5. So plus 296 comes along for the ride. 360 comes along for the ride. These guys combine to make 301. So 360 is still living there. I now have a one-step equation where all I have to do is subtract 301, subtract 304, and x equals 59. 59. So there you have it. That is the angle addition postulate in action. Fun. Find x if AB is an angle bisector. All right, if AB is an angle bisector, that means these two angles are congruent, so I can set them up equal to each other. So I don't need the parentheses. 4x plus 1, this angle right here, is going to equal 33, that angle right there. So it's a two-step equation. Subtract 1 from both sides, drop down the 4x, 4x equals 32. Divide 4 from both sides, x equals 8, and I'm done. Find the midpoint, no graph, and instead I have 2 points, 5, 2, negative 4, negative 3. The midpoint formula says let's take one of these points, doesn't matter which one's which, and call it x1, y1. Let's call the other point x sub 2, y sub 2. The midpoint formula is this. It's a big point, and the x value is going to be x sub 1 plus x sub 2 all over 2. And if you're thinking, that's like the average, it is like the average. Average means middle. Okay. Y sub 1 plus y sub 2 all over 2 gives me the midpoint for the y value. Now it's just a matter of plugging stuff in and doing a little bit of math. All right, so x sub 1 is 5 plus x sub 2 is negative 4 all over 2. Y sub 1 is 2 plus y sub 2 is negative 3. All of that over 2. 5 plus negative 4, or 5 minus 4, is 1, so 1 over 2. 2 plus negative 3, or 2 minus 3, is negative 1 over 2. So we'll slide that negative out there because I don't have enough space to draw another thing underneath. And so that's my midpoint. You know, the kids tell me that this is really mid. And I'm like, it sure is. Mid means like average, I guess. I don't know. I'll check Urban Dictionary. Like and subscribe. Find the distance between the 2 points 8, 5 and negative 1, 3. Now, I could graph that and do what I did in a previous video and make a right triangle, but I ain't. I'm going to use what's called the distance formula. The distance formula says I'm going to take a big square root. I'm going to do in one square root x sub 2 minus x sub 1, square it. I'm going to add y sub 2 minus y sub 1, square that. That's the distance formula. I'm going to label u x sub 1. I'm going to label u y sub 1. I'm going to label u x sub 2. I'm going to label u y sub 2. Now, if you're looking at that and saying, man, that awfully looks like Pythagorean theorem, but with points instead of lines and sides, you're absolutely right. It is the Pythagorean theorem. So a lot of similar stuff is going to happen here where we square things and maybe square root it. Maybe something nice happens, maybe not. I don't know. But this is the distance formula. And if you look online and say, oh, I saw online that this is supposed to be x sub 1 minus y or x sub 2. Doesn't really matter because whether this is positive or negative, once you square it, it's going to be positive anyway. Who friggin' cares? So D is going to equal a big square root. Inside the first parentheses, I have x sub 2, which I called negative 1, minus x sub 1, which I called 8. Square that, plus y sub 2, which is 3, minus y sub 1, which is 5. Square that. Inside the square root, I have negative 1 minus 8, which is negative 9 squared. See what I mean? This is just going to become positive anyway. Plus 3 minus 5 is negative 2 squared. Okay, let's bring that up here. The square roots are getting smaller. Negative 9 times itself is positive 81. Negative 2 times itself is going to be 4. And that gets me the square root of 85. I'm trying to think, can I break that down any further? No, I'm trying to think like if I go and make a factor tree and try to rip it apart, that gets me, 17 and 5, so that does me no good. So this is it. I'm stuck. I'm stuck at an ugly number. Now, if you had a teacher that said, well, what is that as a decimal? It would be 9 point something, because I don't know what the square root of 85 is, but I do know that the square root of 81 is 9. So something that's bigger than 85 is going to be something that's bigger than 9. So 9.2, blah, 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 blah. But whatever your calculator says, I'm not a calculator. I'm a human. I'm a human being, and I have needs, and I need you to smash that like button. All 3 of you watching this, thank you. Statement: all rectangles are squares. Provide a counterexample proving this statement is false. What is a counterexample? Well, a counterexample is a statement, a sentence that shows you and proves you that this statement is not 100% true. Okay, so like if I were to say all cool guys are 23 years old, that's not true because I'm cool and I'm 28. So how can we do that here? How can we provide a counterexample for all rectangles are squares? Well, that's not true because some rectangles have sides that are not, there's an S there, all the same. For example, this guy, if I can draw correctly, is a rectangle, and these 2 guys are the same. These 2 guys are the same. That's a rectangle, but it's not a square. So basically, when you see a statement that says all or every or something like that, you're looking for a reason why that all or every is not true, and that's what a counterexample does. It shows you the lies, just like social media. Show that each conjecture is either true or false. So, all right, so I've got two statements here, and I need to show if the statement is a correct statement or not a correct statement. The sum of two even numbers is always even. So let's try a few out. Two even numbers. 2 plus 6 is 8, even, check. 10 plus 16 equals 26, even, check. How about 2 plus negative 2 is 0, which is technically even, check. So it looks like no matter what two even numbers I add, it's going to be even no matter what. So is this a true statement? Yes, it is. That's a cat. Now, the product of two negative numbers is always negative. Is that true or false? Well, let's multiply two negative numbers together. Negative 3 times negative 4 is positive 12. Well, here it says the product of two negative numbers is always negative. Well, immediately I try one of them and it's false. So is this true? No, this is false. This says up here true or false, and I'm saying yes or no. I just wanted to say yes, because I like saying yes. Like and subscribe. Identify the hypothesis and the conclusion of the conditional statement. A conditional statement says, if blah, 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 then blah, blah, blah. It could also be written like this, P then Q, where P is your hypothesis and Q is your conclusion. If P, then Q. This is already written to us as an if-then statement. So, fairly simple. The hypothesis is going to be the phrase after the if. So if a cat hears a cat opener or a can opener, I don't want to know what a cat opener is. If a cat hears a can opener, the conclusion is going to be the phrase following then. So then it will come running to the kitchen. So conclusion, it will come running to the kitchen. Okay? So conditional statement, if blah, then blah. After if is the hypothesis, after then is the conclusion. And it sure is easier when it's already written to us as a conditional statement like this one here. Cats. Write each. If a cat sees a laser pointer dot moving, then it will chase it. All right, so we have ourselves a conditional statement which is in the form if P, then Q. P is my hypothesis. If a cat sees a laser point dot moving, that is P. It will chase it is my Q. What I have to do is turn all of these into the converse, the negation, the inverse, and the contrapositive. So let's start out with the converse, which is a brand of shoes. A converse says, let's just switch the Q into P. If Q, then P. We'll write that out in a little bit. Negation has you do P, then not Q. The inverse has you take the original but put nots in front of both of them. Speaking of converse, nots. And the contrapositive is you flip everything and make everything negative. So not Q implies not P. So let's do a little bit of writing. Converse. If a cat will chase it, then a laser pointer dot is moving. So I hate the way that that's worded, but that's it. If a cat, and let's actually be a little bit more specific. If a cat chases a laser pointer dot, if a cat chases a laser pointer dot, then it is moving. So what you saw me do here is I moved some words around to make the sentence make sense. If I were just to go in reverse and say, if it will chase it, then a cat sees a laser pointer dot moving. That's not wrong, but this just sounds better. If a cat chases a laser pointer dot, then it is moving. I'm kind of happy with that. Let's keep going though. Negation. So the first part doesn't change. If a cat sees a laser pointer dot moving, okay, so the first part didn't change at all, word for word, then it will not chase it. Then it will not chase it. So that's what that little squiggly means. That means we're going to take Q and make it a false statement or make it a not. There you have it. Inverse is we're going to write out the same thing but throw a not here and a not here. Oh, speaking of cats, one just walked into the room that I'm recording in. So hello, little kitten. No, please. I swear there's a cat here. All right. If a cat does not see a laser pointer dot moving, if a cat does not see a laser pointer dot moving, then it will not chase it. Okay? So P, thank you, not. Last but not least, we have our contrapositive, which is basically you rewrite out Q but throw nots in front of both of those. So if a cat does not chase a laser pointer dot, then it is not moving. So as you can see, these aren't fun. And the purpose of these videos or this series of videos, gross geometry, is there's really no math here at all. You're just making logical statements which will lead into something called proofs where you need to know a whole lot about logic and reasoning and all that stuff. And isn't that life? Cats and logic. That'll probably be the name of my memoir. Like and subscribe. Write the biconditional statement for if lines intersect at 4 right angles, then the lines are perpendicular. Biconditional statements are if and only if statements. Okay, so I have children, and if my children are like, Dad, can we watch television? And if I were like, yeah, but only if you do your chores, then my children can watch television if and only if they do their chores. Well, lines intersect at 4 right angles. If that happens, then the lines are perpendicular. Okay, well, here's my if. So that's actually going to be my second part of the sentence. My first part of the sentence is lines are perpendicular if and only if they intersect at 4 right angles. So I know it sounds kind of backwardsy, but it all depends on if one depends on the other. Use the word depend a lot. But that's how this one works out. You got to kind of switch the words around a little bit, but I threw the if and only if. By the way, some teachers use this for if and only if, and if you're like, oh, that teacher doesn't know how to spell. No, a lot of teachers use that for if and only if. But those are biconditional statements. If. The law of syllogism. There's nothing funny about the law of syllogism. Law of syllogism says if P then Q, and then Q then R, then P then R. Skips out the middleman. All right. If I am cool and if someone is cool deserves you to like and subscribe to my channel, then I deserve for you to like and subscribe to my channel. Law of syllogism. If it rains, then the ground gets wet. Neat. If the ground gets wet, then the grass becomes green. Neat. Using the law of syllogism, what can you conclude? Well, if it rains, that's P. Q is going to be the ground gets wet. The second statement starts out with if the ground gets wet. So what we're going to do is cut out the middleman and go right from P to R. If it rains, then the grass becomes green. If it rains, then the grass becomes green. And look at that. I chose a green pen just for this. I did it on purpose. All right, so this is the end of part 1 of gross geometry, where we aren't really doing a whole lot of math. We're doing a lot of logic. And logic is required for stuff that we will deal with called proofs, and that'll be the next volume of my gross geometry series. Thanks for watching. Law of detachment is one of those really weird rules. Basically, if I tell you that if P then Q is a true statement and P is true, then Q is true. Now, that's usually used when you have problems like this where not everything is as clear-cut as it could be, and so you're kind of going like, oh, we have to use logic now. That's what the law of detachment is. It's just logic. If Alicia scores 85 or greater on her test, she will earn an A on her final grade. Terrific. Alicia scores 89 on her test. What can you logically conclude? Well, if she scores 85 or higher, she gets an A. What did she score? 89? Oh, well then what can we conclude? She will earn an A, make it a big A, as her final grade. So law of detachment, kind of stupid. That's why this is called gross geometry, because gross geometry is kind of stupid, but, you know, logical. So there you have it. Welcome, ladles and jelly spoons, to an introduction to two-column proofs. What's a two-column proof, you ask? Well, I give you some information, probably a picture. I ask you to go from this thing to that thing, and I write out a two-column proof where I write out statements and reasons showing why this is allowed to become that. Think of the statements as you're solving a two-step equation, right? And along the way, you show your work and you're just kind of whittling your way down, blah-de-blah-de-blah-de-blah-de-blah-de-blah. Well, the statements on the left side are basically the work that you show. Now, what I would do is I would say, oh, subtraction property of inequality, division property of inequality. Those are my reasons. So a two-column proof, and I'm going to quick clear this out, a two-column proof has me list all of the work that I would show to get from my given to my prove, and my reasons would be all the theorems and the postulates and the blahs that I know that have this make sense. Now, since this is an introduction to two-column proofs, I'm giving you all the statements, and it's my job to come up with the reasons. So, whenever you have a two-column proof, 99.9% of the time, your first statement and reason is going to be your given. Write that out. If this was completely blank, you would always start out with AC equals AB plus AB, and my reason is because that's the thing that you gave me, dummy. Step 1, finished. Step 2 says AB plus BC equals AC. Now I have to look at this information and try to be like, okay, well, where did I get that? Did I get that from up here? No, I didn't. Let's look at my picture, AB. Oh, there's AB. So that matches up with that. BC, there's BC, so that matches up with that. And oh yeah, I guess it would make sense that if I added those together, I would get AC, which is the whole thing. Now, whenever I take two or more segments and add them together to get a bigger segment, that's called the segment addition postulate. Let's write that out. Segment addition postulate. One more time, whenever you have to add segments, two or more, to get a larger segment, it's called the segment addition postulate. Similarly, when you do proofs, when you do the same thing with angles, it's called the angle addition postulate. So if like angle 1 plus angle 2 equals angle blah, 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 angle addition postulate. That's step 2. We're done. Now, they went from AB plus BC equals AC, and they turned that into AB plus AB equals AB plus BC. What gives them the right to do that? Well, usually, not every time, but very often, a step or a statement comes from a combination of two previous statements. This is what I notice. That AC is AB plus AB. AC also happens to be AB plus BC. So if AC is this and AC is that, then this equals that. All I'm doing is I'm saying since AC equals AB plus AB, there you are, and if AC equals AB plus BC, there you are, then AB plus AB equals AB plus BC. This is called the substitution property of equality. Now, I'll just say substitution property, and leave it at that because space. Now, how did I do that? I replaced AC with AB plus BC. So technically, or I could just write it out. I mean, either way, I wrote it out. You could also use the transitive property, but I already said substitution. We're leaving it at that. Now I have AB, and let me clean this up so I can see it because I'm at my last step and I need to see how I can get from 3 to 4. AB plus AB equals AB plus BC. All of a sudden, it's now AB equals BC. Well, how can I go from two things on the left and two things on the right to one thing on the left and one thing on the right? I would have to get rid of one from each side. There's an AB on the left. There's an AB on the right. If I subtracted AB from both sides, that would cross out and give me AB equals BC, which is that guy right there. So what did I do to both sides? I subtracted. So what is this? The subtraction property of equality. I can squeeze it in. Depends on what kind of teacher you have. They might be okay with you saying subtraction property. I like to write out as much as I can because it sounds a whole lot better. But this is an introduction to a two-column proof. And with two-column proofs, again, you're given information, you're told to prove something, and you have to go from step A to step whatever and explain what you did. And oftentimes with segments, we're going to have to do segment addition postulate, oftentimes substitutions involved. And in this case, we had subtraction too. So lots of fun. I enjoyed it. Thanks for watching. More to come. All right, kids, what do we have here? We have a two-column proof and a whole lot of blanks to fill in, a whole lot of them. In the previous video, I gave you all the statements and I had to give you all the reasons. Well, now we're everywhere. And what I have here is a bunch of angles glued together. I have a straight line here. I got what looks like it could be a right angle, but I don't know. I got these angles are next to each other. Anything could happen. But what it's telling me to right off the bat is angle AEB, which is 1, 2, 3, is complementary to angle BEC. So angle AEB is complementary to BEC. let's get started. And what I have to show is I have to show that the measure of angle AED, which is U, is 90 degrees. So got a lot of work to do. Step number 1 is always your given. So there you have it. Step number 1, AEB is a complement of BEC. That was my given. My reason is given. 90% of the time, 99% of the time, your first step in a 2-column proof is going to be your given. So let's not burn too much brain energy on that. Step 2, statement 2 is, I don't know. But it says the reason is definition of complementary angles. What does complementary angles mean? 2 angles that add up together. Oh, so what they might want us to say is by definition of complementary angles, the measure of angle AEB plus the measure of angle BEC is going to be 90 degrees. All right, I can handle that. Measure of angle AEC is equal to the measure of angle AEB plus measure of angle BEC. Okay, well, what's AEC? All right, this whole thing right there. And that's the measure of angle AEB plus the measure of angle BEC. Oh, I see. They want me to show that this whole thing is that guy plus that guy. Well, whenever we add 2 angles together, the reason why we're allowed to add those angles together is because of the angle addition postulate. In a previous video, you saw me do segment addition postulate, and then I said later we're going to do angle addition postulate. Well, here we are later. I hope you're watching all the videos, otherwise none of this made sense. But angle addition postulate is a rule that says, hey, you're allowed to say that one whole angle is equal to 2 angles added together. The measure of angle AEC is 90 degrees. Now, that's because the measure of angle AEC is 90 degrees. Now, usually when we get to a part where we look up here and we don't see a whole lot, we're trying to piece 2 previous pieces of information together. I see a 90 degrees up here. I don't see any 90 degrees in my given. I don't see any 90 degrees on my picture. And you're not allowed to go from your proof. So I have to look at previous information. And I see that 90 degrees lives up here in step 2. Let me give you a circle. Also, the measure of angle AEC is right here. Oh. AEB, BEC, AEB, BEC. I know the measure of angle AEB plus the measure of angle BEC is 90 degrees because if I were to say that guy equals 90 and that guy also equals AEC, then AEC equals 90. This is the substitution property. And if you're like, whoa, 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 what just happened? Let me explain it again. Let me explain it again. If I gave you a problem that was like A equals B and B equals C, I'm allowed to say A equals C. Because if A is B and B is C, well then B, these guys are the same thing too. So 90 equals ABBEC. AEC equals ABBEC. So since AEC equals 90, that's because we just replaced that guy and that guy with each other. Okay, substitution property. Now we're down to the measure of angle AED plus the measure of angle AEC equals 180 degrees by the definition of supplementary angles. So even though I don't say supplementary up here, I see that all of this gives me a perfectly straight line. So they're saying, well, let's just add AED, which is U, and AEC, which is U, and make it 180. My next step is to do the substitution property of equality. So what they want me to do is they want me to replace something up here so that I can go from 5 to 7. Now, if I just said something about AEC equaling 90 degrees and I see AEC appear and I kind of don't want it to be there anymore because it's now gone in 7, why don't I just replace AEC with 90? the measure of angle AED plus 90 equals 180 degrees. Now, that is substitution because I substituted 90 for AEC. My last step is to go from AED plus 90 equals 180 to just get rid of that 90 and make it 90 over here. How do I do that? Well, if I subtract 90 from both sides, then AED equals 90. If I just subtract 90 from both sides. So what am I going to do? The subtraction property of equality. Subtraction. Ugh, looks terrible. Property of equality. And so there's my proof. Okay, this is still like an introduction to two-column proof. So again, you're going to see me filling a whole lot of blanks. But this used a lot of angles and a lot of reasons. But a lot of angle addition problems and a lot of segment addition proofs are going to involve you like adding stuff, substituting information, and probably doing some kind of solving an equation type thing, which is exactly what we did here. It's just this one was a lot more involved than my previous video if you watch that. But we're on our way. Not easy stuff. That's why this is called gross geometry, because it's not that much fun unless you're sick. In which case, gross geometry should be right up your alley. Given the measure of angle 1 equals the measure of angle 3, I need to prove that EBA, which is this chunk right here, is equal to the measure of angle CBD. That chunk right there. All right. I got myself a two-column proof. All of my reasons are given. Some of my statements are given. I need to go from 1 to 6. Well, if you are watching my videos in order, if you're watching my gross geometry videos in order, which if you're not, shame on you, the two previous examples looked very similar to this, where my first statement was always a given. It even tells me it's a given, so why would that change? 95, 91, 90, 10, 90 billion% of the time, your first statement's going to be your given for a two-column proof. So that's done. Now what? They are going to tell me that the measure of angle EBA, which is this whole thing right here, EBA is 2 plus 3, angle addition postulate, makes sense. We saw that in the previous video. The measure of angle EBA is also 2 plus 1. How do I know that? Well, 3 is 1 because we said that up here. So if 3 is 1, then my reason from turning 3 into 1 is because 3 is 1. That's the substitution property of equality. So we've seen that before. They could have made this problem a little bit more difficult and made me guess that, but I'm not going to complain. So now it says the measure of angle EBA equals blank from the commutative property of addition. Now, the commutative property of addition means that if you say something like 3 plus 1, it's the same as 1 plus 3. You're going to look at this and say, this is extremely picky. I don't like it. And you're kind of right. But the difference between 3 and 4 is 3 says 2 plus 1. 4 is going to be 1 plus 2. Pointless? Yes. But many proofs are. Proofs are annoying, but commutative property, if it says, no, you need to use the commutative property, just think of a commute to work. If you take route 3 to work and then take route 1, then on the way home, you're going to take route 1 to route 3. Makes sense? It should. So now the measure of angle 1 plus the measure of angle 2 equals stuff from the angle addition postulate. So let's go back to our picture, because the last time we used the angle addition postulate, we said that 2 plus 3 is EBA. Now I want 1 plus 2, and 1 plus 2 is CBD. So we are going to say that the measure of angle 1 plus the measure of angle 2 is the measure of angle CBD due to the angle addition postulate. And so now I'm at the very end. And what always happens at the very end? What you're trying to prove. So we could say the measure of angle EBA is congruent to the, well, equal, is equal to the measure of angle CBD by the transitive property of equality. The transitive property of equality is kind of like the law of syllogism. The law of syllogism says, hey, if A equals B and B is C, then just skip the B and go right from A to C. A to C. Transitive property is the same thing. So what are they doing here? Way up here, they say that EBA is 1 plus 2. 1 plus 2 is CBD. So let's skip the middleman and say EBA is CBD. And that was supposed to be EBA. So let me erase that and make that look better. Otherwise, that would not be a good way to end this video, to have a wrong statement up on the picture. But despite that tiny little mistake, that's my guys. That's my introduction to column proofs. Not a lot of fun unless you have a death wish. So there you go. Make a paragraph proof. A paragraph proof is basically like a flow proof with more words, more sentences. If you remember from a previous video, those of you who watch all my videos in order, the flow proof looked like this. Right, where we said the statement is blah 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 and the reason is this, and the statement is blah 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 and the reason is this. Well, now instead of having a picture of a flow proof, it's going to be just in flat out sentences, and we're going to make it sound like a little essay. Okay. All right, so what do we have? We have given KMN, so KMN is 28 degrees. I can handle that. We're also given the fact that PTS is 118. I have to prove that JMK, the angle, this guy right here, is congruent to angle STR, which is this angle right here. Okay, so I have to show that these guys are congruent by using numbers like 28 and 118. Let's start out with the given like we always do. We are given, now keep in mind, little warning, just because I write it out this way doesn't mean it's the only way of doing it. Those of you who watch my videos know that I stumble and fumble over my words all the time. I accidentally misspeak. I misspell words all the time. Don't be like, wow, that guy is the Lord of grammar. No, trust me, no. It's just the way that I'm doing is a way that's correct, but certainly not the only way. So we are given that the measure of angle KMN is 28 degrees and the measure of angle PTS is 118 degrees. Period. End of sentence. All right, how can I start connecting these dots? I need to find a way to connect green with purple here. So why don't I find out what green is? Why don't I find out what purple is? And I'm sure at some point I will find out that they're the same. Now, what I know is I see that right angle right there. Okay, that right angle right there. So what I can say is that angle JMK and angle KMN add up to 90 degrees by the definition of right. No, let's not say right. Let's say complementary angles, because right angles implies one angle. So let's say by definition of complementary angles. Complementary angles is just more proper. Complementary angles. So maybe what I should have said is that the measure of angle JMK plus the measure of angle KMN equals 90. Probably a better way to say it. Already my paragraph proof isn't falling apart. It's just much worse than it has to be. Now, if that's the case, what I can do is I can replace measure of KMN with 28. Using substitution, the measure of angle JMK plus 28 equals 90. Now, I can solve for JMK by subtracting 28. So, the measure of angle JMK equals, what is that, 62 using the substitution property. Nope, the subtraction property. Subtraction property. Cool. So what I have that you are now 62. Now, a lot of this, most of you kids watching this would be like, dummy. I know that I could just do 90 minus 28 and you wrote out like half a paragraph just to say that. Do we really have to do these for proofs? Yup. That's why this series is called gross geometry. It's not called easy happy time geometry. Easy happy time geometry is for you Khan Academy jerks. I apologize to the Khan Academy jerks. If they want to sponsor any of my videos, I'd be very happy. Now, I found out what the measure of angle JMK is. Why don't I say that the measure of... Now, what I'm going to do is I'm going to avoid writing so much here and just kind of jump right to that and say that the measure of angle STP, Stone Temple Pilots, plus the measure of angle PTS equals 180 by definition of supplementary angles. See, these guys add up to make 180. And I'm hoping by doing 180 minus 118, I get 62. I do. And if I get 62, then I can show that these guys are the same. So what I can do now, since I can't ever make it that simple because proofs are a nightmare, what I can do now is I can go back up here and remember that PTS is 118. So the measure of angle, was it supposed to be STP? Wait, that's an R? Oh my gosh. R. So that Stone Temple Pilots joke is dead. And that's still PTS. STR, PTS. All right, I'm good. I just, I don't have my glasses on, so I really can't see anyway. The measure of angle STR, okay, plus, let's change PTS, is 118 equals 180 using substitution. If I subtract 118 from both sides, I get that the measure of angle STR equals 62 using the subtraction property of equality. Now that I know that the measure of angle STR is 62, and I found out up here that the measure of angle JMK is 62, I can now finally say that JMK is the same as STR. But first, I have to say the measure of JMK is the same as the measure of angle STR using the transitive property. Transitive property says if A is C and B is C, then A is B. So that's what transitive property is. So using the transitive property, and now if their measures are the same, we can finally end this thing and say angle JMK is congruent to angle STR by definition of congruence. I nailed the spacing. Very proud of that. But this is a paragraph proof. Okay? This is a paragraph proof. Normal people, including myself, before you start your proofs, what you really should do is you should be like, well, if my job is to prove that this guy is the same as this guy, I know that that's a right angle, so 90 minus 28 is 62. And this is 180 degrees, so 180 minus 118 is 62, so these are the same. And this is what you have to do to prove it. It's the proof that's a nightmare. And it is a nightmare. But the best thing about nightmares is eventually you wake up. I think that's in the Bible. Or if I just made it up, I don't know. Like and subscribe. Write an indirect proof to show that the square root of 18 is not 3 root 6. What the crap is an indirect proof, you ask? Well, let's first assume, the opposite of the conclusion here. Conclusion. I don't even know if that's spelled right. What's the conclusion? That's the conclusion. The second part of what you're trying to prove. Let's assume the opposite. In other words, to do this problem, we're going to assume that the square root of 18 is 3 root 6. Then what we do is we do some work, whatever work we have to do, and arrive at a contradiction. What's a contradiction, you ask? It's a lie. Basically, your girlfriend is all like, you talking to girls, and you all like, no, I'm not. And then she like, let me see your snap. And you're like, oh, all right. And then you hand over your phone and she like, I'm going to assume that you're telling the truth, but I'm going to check your phone anyway. And she look at your phone and she slides into your DMs and she sees that all these other girls are sliding into your DMs. So her assumption that you were telling the truth is wrong. Therefore, you are lying, and therefore you are talking to girls and looks like you're finding yourself a new girlfriend. What we're doing is we're going to assume the opposite. Find out that the opposite is wrong and say, well, that's wrong, so therefore the original statement that we are given was true. Okay? So one more time, we're going to assume the opposite of this. We're going to do some math and find out that that's not right, which means if the math doesn't work out, they can't be equal. Therefore, this can't equal that. So let's try it. Let's give it a shot. Let's give it the old college try. Okay. Now, as with all of my proofs and paragraph proofs, just because it's the way I write it doesn't mean it's the only way. It's just a way that is correct. All right. So let's assume that the square root of 18 is 3 times the square root of 6. Well, I know from a math teacher named Mick Parrish, the math teacher go, that the square root of 18 can be broken down to the square root of 2 times 3 times 3. And you can rip out a group of 3's, and you are left with 3 times the square root of 2. Wait a minute. Root 18 is supposed to be 3 root 6. We just found out that root 18 is actually, and let me write it out so it looks a little bit better, root 18 is actually 3 root 2. Okay, so I'll say that. But we assumed this, but root 18 is actually 3 root 2. Therefore, root 18 can't be 3 root 6. So we'll say that. Root 18 cannot be equal to 3 root 6. And we're done. That's our indirect proof. We assume that the opposite of that occurs. We find out that our assumption is wrong. Therefore, since our assumption is wrong, the original assumption must be right. Indirect proof. All about you cheating on your girlfriend or boyfriend. Make an indirect proof. If the measure of angle A, that guy, and the measure of angle, is 64, and the measure of angle B, that guy, is 116, then A and B are supplementary. What's an indirect proof? I already made a video on indirect proof, so I'm not going to break it down. But first things first, we are going to take the second part of what we're trying to prove and assume the opposite. We're going to assume that they're not supplementary. Then we do some math, find out that we're wrong, and therefore they must be supplementary. Okay, so that's indirect proofs in a nutshell. You assume the second part is a lie, do some math, and find out, whoopsies, I was actually wrong by assuming that, therefore the original must be true. So let's assume that angle A and angle B are not supplementary. Supplementary means they add up to 180 degrees. Supplementary means they add up to 180 degrees. Let's get a different color. The measure of angle A is, well, I'll say the measure of angle A plus the measure of angle B is the same thing as 64 plus 116, which is 118. So we're assuming that the measure of angle and B are not supplementary, but when I add angle and B, A and B, but the measure of angle A plus the measure of angle B add up to 180, which means they are supplementary. And I can end it right there. I mean, I'll need to make an extra sentence to make it sound prettier. I know in my previous indirect proof video, I made it an extra sentence. But again, you know, clinging onto the way that I structure this is not necessary. All you have to do for an indirect proof is assume the opposite of the other part, the second part, find out that you're wrong, which means the original thought, the original statement is actually correct. And that's what we did here. Indirect proofs, tons of fun. All about lying.